Hello everyone. So today we will talk about finding min and max on a given domain. So let me explain to you what I mean by this. And we're going to do two examples today. So let's say you have an expression y equals x squared plus 2, right? And I want to find its min and max. Now, if I don't have any domain restrictions, I can easily see my min. So what do I mean by min and max? So, the minimum is the lowest point on the y-axis that this function can ever reach. The maximum is the highest point on the y-axis that this function can ever reach. So the question you should be asking yourself, does every function have a min and max? And the answer to that is absolutely no. For example, let's take a look at the function that we have over here. This is a parabola, right? This is your regular quadratic function. Does it have the lowest point? Yeah, for sure, right? It's this vertex over here, okay? Does it have a highest point? Well, no. It keeps on going on forever until it reaches positive infinity on both sides. And that's okay, okay? So you can have min, you can have max, or you can have none. But I will tell you this, if your function has a vertex, right, then you should be looking at mins and maxes, right, and seeing if that vertex is a min or a max. But even then, you can have a situation where you don't have a min or a max and you have a vertex. So let me show you some examples. Take a look at the blue function. This is y equals x cubed, right? This function has neither min nor max. It goes on forever in both directions. So this end will reach negative infinity at some point. This end will reach positive infinity. It just goes on forever. There is no min or max. Okay, what about some other functions? Well, here's another fun function, right? This is x cubed minus 2x. And it does have two vertices too, right? This is a vertex and this is a vertex. But once again, this function seems to go on forever in both directions. In general, when we talk about polynomials, all polynomials that have odd powers, 3, 5, 7, etc., right? And even 1, right? The equation of the line definitely counts, right? They will always have the range of all real numbers. So the range of all odd-powered polynomials is all R. Okay, so it goes all the way to negative infinity and positive infinity. Awesome. Awesome. So what if I'm interested in a min or a max on a given interval? So what on earth do I mean by that? Let's say I want to look at my original function, which was y equals x squared plus 2. But I only want to look on the interval between x equals negative 2 and x equals 1. So let's look at my function on that interval and that interval only. So I'm going to look at Desmos and x equals 1, and these are included, okay, of course, okay? So my x equals 2 is somewhere over here, right? And my x equals 1 is somewhere over here. You can see I'm dropping the little. So this is the interval. The interval in between is what I'm interested in. Everything else, it's as if all of this does not exist. Another way to write this down is, of course, x is less than or equal to negative 2 and x is less or equal to 1, greater or equal than negative 2. And I can even write this down in Desmos. This is absolutely possible. I can do x is less than or equal negative 2, greater or equal to negative 2, excuse me. Okay? And x is less than or equal 1. And you can see I would be looking at my function in the interval where there is an overlap, right? This interval only. And I want to find a min and a max. Well, what are those? Those are exactly what you would think they are. They're the highest and the lowest point on this interval. So when I look at this interval, what is my highest point? Well, let's trace this out. So I'm going up and up and up and up and up. And the point is clearly negative 2 and 6. Okay? And it's the edge of my interval, but it's not always the case that it's the edge of my interval that's going to be the highest point, right? So this point over here, this is my max. Now, if I'm talking about the max, am I talking about x values or y values? Well, let's think. We're judging max based on its y values, right? So you can say that your max is at points negative 2 and 6. However, when you are asked for the value of the maximum, you're going to say f of x or y, right? Doesn't matter whichever it is 6. You're always looking for y values. Okay? And that should make sense because we are looking at the y values, and those are the ones important in here. All right. Well, now that we have looked for the max, right? Let's find the min, right? So I'm going to go ahead and trace this function again, and I keep going down, and I go down all the way until x equals 0, right? And then I start going up. So it's clear that my min is going to be at x equals 0 and y equals 2. So this number, this lowest point, is going to be my min. Okay? So this one is 0, 2, and of course, I'm going to put f of x equals to 2. This is my min. Okay? All right. So these are mins and maxes. Awesome. So let's do some more practice. I'm going to do a couple more problems. So the next one I want to do is our good friend. Over here, x to the third plus 2, let's do it minus 2x. This kind of strange function. And I want to look for all the values between x equals negative 2 and x equals 2. So this is my domain over here. From negative 2 to 2. Or if you like, I can write down x is greater or equal than negative 2 and less than or equal than 2. So once again, I'm going to do the same thing I did in Desmos. I'm going to go ahead and split up that inequality. X is greater or equal to negative 2. And x is less than or equal to 2. And once again, I'm looking at my overlap. So let's look at my mins and maxes. And I'm going to go ahead and trace out my function. So this is one of my vertices right here, right? And here's another one of my vertices. So they kind of jump out at you, but the question is, are there points lower than this? And if you trace your function, you can see that this leg over here goes way beyond that point and goes all the way down up until we reach negative 2 and negative 4. Okay? So that would be our lowest point on this interval. So this point is your min. And of course, it's f of x equals negative 4. Remember, y values. So now let's go ahead and look at this max. So I've got a vertex over here which looks like a max, but the reality is we have a leg that goes way higher than this. And once again, I'm going to find my max somewhere on the edge of my interval. So over here, where my function hits the edge, for some reason I put 3. Let's put 2. There we go. Now it makes more sense. So somewhere over here, where my function hits the edge, right, and I hit 2 and 4, right, that is my max. So let's go ahead and write this down. So this is my f of x equals 4, okay? And this is, of course, my max. Awesome. So let's do one more final practice problem. And what if I don't have a polynomial? What if I have a rational function? What if I have y equals 1 over x plus 3? So now I have this kind of thing, right? And I want to find out everything between two very important points. I want to find out everything between y equals -4 and y equals 1. Okay, so this is my -4, this is my 1. So let's go ahead and take a look. What is going to happen? X is greater or equal to -4, and x is less than or equal to 1. So this overlapping region, again, what I'm looking at. And when I trace this thing, when I trace this function, it goes on forever to -infinity, which means I have no max. I have no min, right? So my min is literally -infinity, so no min. Well, what about my max? This other edge of this function goes all the way to +infinity. So it turns out I have no max either. That happens. So is there an interval where over here I would have a min or a max? Sure, of course there is, right? But it's not the one that we tried, right? So how about this one? What if I'm looking at two intervals, x greater than greater than 1 and x less than or equal to -4. So I'm doing the opposite of what I just did, right? So I'm going to have x less than or equal to -4 and x greater or equal to 1. So now I have two regions, and I can easily find my min and max here, because if you trace out this graph over here, it tries to get to 0, but it will never cross. But over in this region, at this point, -4 and -1, I actually do have a min. Because if you look at my other function on the other end, this function, this end of the function, will never cross the x-axis either. So this one is my min, all right? So f of x equals -1. And let's look at the max. So I know that I will not find the max on this side because this will never cross the x-axis, and the other end is actually above the x-axis. So what's the highest point over here? Well, once again, I'm looking at the edge, right? So my highest point over here is f of x equals 1/4. Very, very, very straightforward.